So now I'm going to invite Thomas. He's from the Netherlands. And just after his presentation, we are going to have someone who is going to share an organism in Brussels who gives grants to young entrepreneurs and young people who have who want to have a big impact. So we are going to sit there. So Thomas, you're from Amsterdam, and you are a very impressive entrepreneur. First, because of the age that you have and the age when you started your project, but also because you have a very impressive and non-linear story. So Thomas, can you just briefly present you? And I think you share your life between Boston and Amsterdam, so I would like you to introduce you.
Well, thank you for that very kind introduction. As Celestine said, my name is Thomas. I'm the founder and CEO of Amylon. I'm from Amsterdam, from the Netherlands. I spend most of my time, as you mentioned, between Cambridge, Boston, and the Netherlands. And the reason for that is I moved part of our company there, which I will tell a little bit about later. Amylon is a CNS company, targets diseases of the central nervous system and specifically diseases of orphan nature, so small patient populations. And we're a spin-out, so I built the company on the inside of a different company called ProQR Therapeutics, which has a remarkable story of its own. Was founded by Daniel de Boer, founder of a CF patient, with the idea to find a therapy for his son. And so it was a fostering environment for young entrepreneurs myself, and I was lucky enough to build the company inside there and spin it out a little over a year ago, launching Amylon as an independent company.
But your ambition was not, has not been, when you started your study, you did not want to be an entrepreneur. You first wanted to be a doctor, and then you changed your pathway. But you always had the dream of helping patients. So can you tell us more how you switched from a doctor to an entrepreneur with the same vision of helping patients?
So, as you mentioned, I did not start out my career as an entrepreneur. I would say it's the opposite. I wanted to be a surgeon, where your career is pretty much spanned out for your entire lifespan. I still don't see myself as an entrepreneur particularly. I always think about entrepreneurs as people, you know, who they say could sell sand in the desert. I was just lucky enough to come into a certain situation. And so my personal background is I went to medical school in the Netherlands, and I wanted to be a surgeon, neurosurgeon. So I'd always been super obsessed with CNS and everything that goes with it. And unfortunately, I have a disease myself, which is called Scheuermann's disease, and it basically meant my spine was very deformed. Now, to fix that, I had to have surgery, and so my spine was fused about 7 years ago now. I grew 10 centimeters in one day, which was a nice growth spurt. At 21 was unexpected. I thought I'd grown all up, but it wasn't the case. And I had to quit medical school, unfortunately, because as you can imagine, it's very physically intensive, and having titanium from here to here doesn't really help, especially if you have shaky hands and you want to be a surgeon. It's a little bit contraindicated. Now, I always said, if I can't be a surgeon, I'll be a snowboarding instructor, because those are the only two things I loved. As you can imagine, I can do neither. I'm not allowed to snowboard anymore, as per my surgeon's request. And so finished my bachelor's degree, and then, but my basis had always been I wanted to help patients, and I wanted to do something in the field of medicine. And I had no idea what to do, and I kind of rolled into biotech afterwards, and found my, as I like to call it, my second love in an industry that helps patients in the same way, with the same mentality, but at a much larger scale. So instead of focusing on the individual, you focus on the entire population.
So when you at some point you decided to change your mind, and you realized you could help patients on another way than being a doctor. And then you started a master degree. And I think that during this master degree, you started the internship, right? You started the internship in a biotech company. And this is from that biotech company that you built the startup. But then the question I think that we are all wondering, how do you start a startup company as an internship, a spin-off company has an internship?
So it's an interesting story. So when I had to quit medical school, I didn't know what to do, and I met this guy who's in the management team of ProQR. His name is René Beukema, and I met him through my uncle to hear about biotech. I didn't know anything about biotech, and we talked, and the more he talked and the more he told about biotech, and he was with Crucell at the time when it was sold to Johnson & Johnson, and he was at ProQR, and I thought it was remarkable what they were doing. And for me, it was a complete discovery, and I thought, this is what I want to do. But you have to start somewhere. Now, I had no formal higher education and no real expertise in any field, and so I figured, I'd like to learn what it takes to make a biotech company tick, and I will try and learn this from the inside out. So I found an excuse to work inside of a biotech company, which was an internship for a master's program. So I started there, and the way that turned into a company is a bit of an odd story. I would say the inception was a conversation I had with my good friend and mentor René, and it literally went like this. I asked him, what does it take to build your own biotech company? And he goes, well, it's simple. Just come up with a drug. And I was like, all right, for what? He's like, what's the biggest disease you can think of? And I said, that's easy, that's Alzheimer's disease. He's like, come up with a drug for Alzheimer's. I was like, all right, I'll try that. I thought it was a joke at the time, but because I was inside a different company, they had a toolbox. They had an RNA therapeutics platform, and I'd always been particularly interested in protein aggregation disorders like Alzheimer's disease and prion disease and, let's say, neurology as a whole. And so I had glasses to look through at a problem that was very well characterized. And I had an idea, which was that, what about cleaning up the mess that's being made? Why don't you just prevent it from an RNA level? Because we had an RNA toolbox to look through, and no one had thought of that before. And I didn't think I was the first one. In fact, I Googled it when I thought of it, and I was wondering what happened when they tried it. And when I didn't find anything, that kind of gave birth to the start of what now became Amylon. Now, obviously, there's 4 years of very hard work and a lot of different steps in between, but that's kind of how it started. It starts out with an idea or with a therapy at which around you build a company. I think most of the biotech companies that exist today are built around an idea. They're not started as a company and then they find an idea. It starts with something that is so innovative and so self-driving that the only logical way to push it forward is to build a company to facilitate that. So in biotech, the company is just a means to a technology.
All right, so my second question was, well, but the second question is like, once you have an idea and the moment you turn that idea into a company, there is a huge gap. And I wanted to ask you, how did you manage to build that startup? But you told us that it's very easy to build a startup biotech. So I think you need to explain us how it is that simple to build a biotech. But more seriously, I would like to ask you, like more, like technical details, like how did you build the team? How did you find the co-founder? How did you raise money? From what I understood, the company you were doing your internship in, that was like an accelerator for you somehow. But I would like to ask you, how did you manage to actually make it happen into a company?
So how to build a company or how to build a biotech company it's a difficult question, but the answer I can tell you how I did it. And I was very fortunate that I had resources because I was inside a different company, but it all starts with data. So the core of what built Amylon and what still is Amylon today is the data that supports our therapeutic program. As long as that is solid, you can build a company around it that sustains it. And so I was fortunate enough to hire a team that could perform experiments and could show that our therapeutic hypothesis actually worked in practice. And then my job was to build a company around it. And so what I did is basically went out into the world and convinced other people off of it. And the way you do that is through a certain structure. And so the first thing you do is you pick your technology and you get the therapeutic field you're in, and you go and talk to everyone there is who's considered a key opinion leader, the best people in the world, the smartest people in the world, and you tell them what your idea is and you show them what you've done. And then if they say, that's a good idea, you should pursue that, that's a validation. It's a very important part of a biotech company, and those people are usually found at the stage of a company as the scientific advisory board members. And so that's the first check. That's the first thing I did. I went out into the world and I spoke with the smartest people, and they were very positive. And that's a very strong reinforcement, because it shows that we're not just drinking our own Kool-Aid. We've got external people willing to put their career and their reputation publicly on the line to endorse your therapy. Now, the second stage is development. So all throughout this entire process, you got to start generating data, and you got to show that your therapy works, and you got to advance it. And we had the resources because we were inside a different company. And so I was building a team around the therapy that was progressing. And ultimately, being inside of a different company became a shackle rather than a support, because the program was advancing at such a pace that the commitment needed to it from a financial perspective was no longer feasible for ProQR Therapeutics, and it was always our intention to create a separate entity out of it. And so then I had to raise funds, and that's basically the job of the CEO, is to raise money for your company to progress forwards. And there's a saying that I always like to think of for CEOs: it's hire great people and get out of their way. And as CEO, your job is to facilitate this. And so I had to raise money, which is a very difficult thing to do. And you do that on a few things. Data you have, the promise of what can be, the validation of others, your scientific advisors, your potential board members. And the last one is timing. Timing is crucial, because we originally thought about going after Alzheimer's way in the beginning. Alzheimer's is a very difficult field to get into. A lot of clinical failures, actually only clinical failures, and so very difficult to get an investment for. Now, during the growth of what became Amylon, we shifted our focus to orphan disorders. And orphan disorders are a difficult kind of, or a different type of challenge, because you have low patient populations, and patients are often difficult to find, and the commercial incentive is not there. Ultimately, what was one of the biggest driving forces behind getting Amylon funded was timing, in the sense that we use RNA therapeutics in the CNS space in an orphan indication. Now, those are risks stacked onto each other. CNS is the most difficult therapeutic area, arguably. RNA therapeutics are an upcoming technology, and orphan is still something that people have to figure out how it exactly works. And then Spinraza was approved. It's an RNA therapeutic for a disease called spinal muscular atrophy. Terrible disease. This affects neonatal children mostly, and they die within weeks after birth. And this is a therapy that uses the exact same technology as we do. It's an RNA therapeutic in the CNS space in an orphan indication. And it happens so rarely that something that was once an idea turns into an actual medicine for patients, that it excites everyone in the industry, even people who do not work in it, even people who are not involved in the therapeutic area at all. Everyone's excited, because it's something that was created from nothing. And that creates a momentum, and that momentum we were able to capitalize on by saying, look, we have the same technologies, we have the same approaches, this is a really good opportunity. And that's what allowed us to that's what allowed me to raise a seed investment and to separate Amylon from ProQR and to launch it as an independent company. And then having that momentum allows you to recruit people. It allows you to get people on your supervisory board, because all of a sudden you go from what is an idea to what is an actual entity that is endorsed by others. And ultimately, having other people endorse you is the biggest driving factor forwards. It's very ironic and paradoxical. Very difficult to get your first investor. very easy to get your next 6. If one invests, the rest will follow. And if you get over that hill, then it becomes easier for a little bit until you have to do your next finance round, then you have to start over again.
Okay, great. So can you explain can you explain the easiest way? What is the science behind amylin, and what are the problems and the disease that the company solves?
So it is my job to be able to explain it to someone's grandmother, so I can do very easily. Our lead program focuses on a disease that's called, that's referred to as Katwijk's disease. And Katwijk is a village in the Netherlands where this toxic protein aggregates in the brain around the arteries, and it causes the arteries to rupture, and these patients have brain bleeds around the age of 45. So it's a genetic disorder. It's 100% penetrant. So if you have the gene, you will have the disease, and it's around 45. So you got to imagine these patients are asymptomatic, and they can have a conversation like this and then literally drop dead. And this toxic protein builds up over time. Now, if you look at the RNA structure of the protein where it comes from, you can identify it as a single piece. We use RNA modulation to get rid of that single piece. And so by doing that on the RNA level, it's never produced on the protein level, and it can never be released and aggregate. And because we're looking at stroke here, you want to prevent it, because once it hits, it's a binary event. You're healthy and then you're not healthy. And so using this technology, we can prevent the formation of that protein, prevent its aggregation, and hopefully prevent the disease.
All right. So very often the people, and especially in science, I think, they believe that you have to hold the PhD, you have to gain credibility, have enough knowledge to do something. But somehow, as a master degree student, you prove that you don't need a PhD. You don't have to have a huge academic background to build a company and to achieve something that could help patients and save lives. So can you tell us about that? That you don't have to be to have a huge academic background.
So I'm not going to say what you expect me to say. I'm a full supporter of PhD and MDA and any higher form of education. I am not by any means the standard or example of the way it should go or has to go. And I often think about, or I talk about this very often, and people say, like Mark Zuckerberg was a dropout, and Bill Gates. But yeah, well, first of all, they were at Harvard. So your alternative has to be really damn good if you want to drop out of Harvard. And they dropped out by choice. So I quit my master's education because I had a better alternative. I did not pursue. If that hadn't happened, I would have completed my master's. I might have done a PhD, because at the end of the day, if this fails, I have nothing. I don't have any education. I have a bachelor's degree in medicine, which is arguably a very useless degree because it only allows you access to a master's program. And so it is possible, but it's not easy. There are not a lot of CEOs you see who do not have a degree. It's a romantic story that I can understand appeals to a lot of people, because it makes you believe that anyone can do it. And I think anyone can, but it is a hell of a lot easier when you've got PhD or MD behind your name, or if you know what you're doing. I had to teach myself everything I know now to keep up with what other people's already knew. And you don't have to be 24 to start a company. It's arguably way too young. And so if you have a better alternative, sure, don't miss out on an opportunity because you want to finish a degree. But if not, it's a very valuable thing. It's a safety net to fall back on. And it teaches you a lot. It teaches you something that you will use, because at the end of the day, I am supported by people who are a lot smarter than I am, or far better educated. And if I surrounded myself with people like me who were not educated, it would be the wild, wild west. Everyone would just be doing what they think is the best thing to do instead of what they know is the best thing to do. And so, yeah, it is possible, but it's not the easiest way. And I would not endorse anyone to quit their education, because it's also very terrifying. So I think there's an argument for both, but it is very valuable. And at the end of the day, it is also if you're doing a PhD or if you're doing an MBA, you're in an environment where you discover things that you can build a company around. I only figured that out because it was inside of a company. I hadn't thought of this in my attic and while I was looking at YouTube videos. So it's a stimulating environment that is very good to surround yourself with.
Okay, thank you very much. So maybe a last question, at least from my side. But what are the next steps for you personally, but also for your company?
So the next step for me personally and my company, those are the same thing. It's two things. We're now in the process of doing a financing round, and that will allow us to bring this therapy into the clinic, hopefully. And so our dream and my dream is to get this treatment into patients, because it's my personal belief that you're a CNS company. Once you can show that you can get a disease into humans, it's very difficult to get a drug into the brain. And it's a terrible disease, and these patients have never had even the slightest inclination that there would be a therapy. The disease has been around for 3 centuries, and never in their highest dreams did they believe there'd be a treatment. And so if I can make that happen, if we as a company can make that happen, that is the highest success that we can achieve, and that is the goal, and that will always be the next step. And practically that requires a lot of money, and so our next step will be fundraising to continue the development of the program.
Okay, thank you. Does anyone has a question? Question to ask? Yeah.
Yeah. So you said that your approach is mainly based on RNA therapy. So are you planning to turn to CRISPR-Cas9 technology, or do you think that would not be necessary?
CRISPR-Cas9, very different technology. So it uses a guide RNA to find its targets. We literally use complementary RNA to block other RNA strands. So CRISPR-Cas9 targets DNA. It uses RNA as a guiding system. We target RNA, and so we don't change the gene, we change the intermediate step, and thereby prevent the toxic protein from being formed. The end result can possibly be the same, it's just a different avenue of approaching it.
Hey, it's not about CRISPR-Cas9, actually, my question.
Be gentle.
What's the mechanism of delivery? How do you highlighted it as one of the big challenges, so can you tell us a little bit more about how you guys are tackling that? Because obviously for CNS, and if you need to get your drug in the brain, that's really the main challenge. So just be interested to learn a bit more.
I asked you to be gentle. No, so it's a very good question. Delivery is considered the cornerstone of any CNS therapeutic because of the blood-brain barrier, and the blood-brain barrier does not allow therapies to enter the brain for good reason. And we use antisense oligonucleotides, which are single-stranded RNA, single strands of RNA. They do not pass the blood-brain barrier. And so to mitigate this, we've partnered with a company called Alcyone Life Sciences, who have a delivery device that uses traditional intrathecal administration, which is an injection in the lower spine, but has a proprietary delivery technology. And so typically when you inject in the lower spine, you get a pooling effect, and so the drug stays where you injected. Now they've developed a technology that's able to overcome the pressure that creates that pooling effect and achieve whole brain distribution. Because it's such a crucial part of any CNS therapeutic, and in fact without it we would be in a very different position. We partnered up with this company in a very early stage so that we hopefully can, if this drug reaches the clinic, can use the combination of that device and our therapy to actually get it into the brain in the areas where we want it to go.
Hi, my name is Yana Slobodenyuk. I have a question about the scale-up of the therapy. Did you already think about this? Is it easy? Is it difficult, especially if we are talking about orphan diseases? How will you produce it in a bigger quantity, let's say?
Very good question. So Amylon focuses on orphan disorders, so disorders of a small patient population, but with the idea that we can pivot that information and pivot that process into larger indications. So for instance, this orphan indication is the genetic subtype of a disease called cerebral amyloid angiopathy, which is the largest cause of hemorrhagic stroke in the world. It's caused by old age, like Alzheimer's is an old age related dementia. Now, the biggest challenge with these disorders is two questions. Who are your patients? When are you going to treat them? If a disease takes 15 years to develop, at what stage do you do therapeutic intervention? If it takes 10 years to do a trial, that's impossible. It'll be too expensive. Your patients wouldn't comply. You wouldn't be able to keep your IP position. And the biggest question in there is your drug safe and does it work? Does it do what you think it does? And the idea with the orphan populations is that we know who these patients are. We know when they'll get the disease because it's a genetic disease and it's very well defined. And if you can show that your drug is safe and that it does what you want it to do, you can cross that over into a larger indication and kind of jump over the healthy volunteer stages, the safety stages, and translate that information in a larger patient population. It's something that's being done in, for instance, tauopathies with parasupernuclear palsy to tauopathies, and it's something that is being endorsed by the regulatory authorities because it, most importantly, it limits the cost of drug development and shortens the time frame significantly. And so instead of 15 years and $1 billion, you need 8 years and $100 million to get a drug approved for patients.
I heard very recently that the first drug for the first RNAi drug for sorry for the pronunciation, but transthyretin-mediated amyloidosis was put in market, and it was the first RNAi drug. So I have two questions: is it related at all? And if it is, will it make it easier for you to develop this kind of treatment?
So the drug in question is called patisiran, which is an siRNA for ATTR amyloidosis. And what it does is it gets rid of transthyretin, I never can pronounce it, which is an aggregating protein causing a polyneuropathy. And this is done by a company called Alnylam. Now, it doesn't use the exact same technology. It uses siRNA, which gets rid of the entire protein, where we modulate the protein. But regardless of that, it's a huge driving force for the field because it shows that targeting the RNA in general is a feasible approach. It shows that targeting a small patient population, as in ATTR amyloidosis, is worth the risk, is worth the effort, and is ultimately a very rewarding process. And in general, as the same with Spinraza, it creates an enthusiasm in the industry that reignites that fire and belief that we can actually get something. Because if you look into the history of patisiran and, for instance, the history and how that translates to us, just a year before, they had a clinical setback because of safety issues. And then everyone looks at the RNA space and says, that's never going to work. They have safety problems. They're not going to get into the target. And all of that changes immediately once something like this happens. And it's a driving force for all of us. And it's also shared in industry. John Maraganory, the CEO of Alnylam, becomes a driving force for so many things, for RNA therapeutics, for orphan indications, for pushing through despite 16 years of setbacks. And so it is altogether a very powerful enabler for a small company as Amylon.
It's very frustrating because I think that we all want to keep talking for a lot of time, but it's also my role to keep the timing. So, Thomas, thank you very much for being here and sharing your experience. Yeah, thank you so much. Thank you so much. Okay, so I would like to invite Victor. So, Victor, you are from London. You arrived this like few hours ago. To be very honest, Victor is one of the guys who inspired me the most as a biotech entrepreneur, and I'm very glad to have you today. So thank you very much for being here. Can you briefly present yourself and explaining how, because you are Belgian, but you live in London, so can you briefly present you?
Hi, everybody. Thank you, Celestin, for having me here. It's a real honor to be able to speak to all of you and to have your attention. So, yeah, my name is Victor. I'm a Belgian citizen. My family's from Paris originally and Normandy. I moved to Belgium here when I was 2, and we fell in love with the country because it's a small but mighty place. So I was naturalized as a Belgian when I turned 18. Big day for me. But I did most of my higher education actually in the United Kingdom. I moved to a place called Sevenoaks when I was 16 years old, and once you're in the British system, the only universities you can go to are British universities. So I went to Imperial College in London to do a master's in chemical engineering. And then that was 4 years of oil and gas. And that was very interesting, and I learned a lot, but I was quite frustrated by how stagnant the oil and gas industry is in terms of innovation. And I was always fascinated by biotech, because we did a little bit of biotech in chemical engineering. We heard the guys from Lund and biomanufacturing, bioprocessing. That was a little bit of what we touched on, you know, antibody production, all that kind of stuff. And I thought, this is very interesting, because as a chemical engineer, you're always designing factories that have the footprint of, you know, several football stadiums. But we, humans, have millions, billions of factories that have the footprint that is invisible to the eye. So how can we leverage the cellular system to manufacture what we want? Imperial was a wonderful place, but I decided to go and do a master's in Cambridge that focused on biotech, and also actually had a business component to kind of talk about biotech as a global business industry. And so we sort of had a morning of business and an afternoon of science, and it was a really nice mix of the two, and that's kind of what got me more into biotech.
So, as Thomas, you also have a non-linear background in terms of entrepreneurship and startup background. So you went to Cambridge to do that master degree, like biotech/business degree. But then you just knew that CRISPR will be the next big thing. And you just, back at that point, you just thought, well, because that's the next big thing, let's just do something about it. And then you start searching, looking at something you could do around CRISPR, and then you build the startups. So can you tell us more about that? Because also I think you outsource this research out of the university. So can you tell us more about that background?
Yeah, sure. So I'll clarify a little bit the story, because Celestin, you know, made 6 years down into 5 seconds, and the beginning was actually a little bit different. When I was at Cambridge, I actually met 2 of my co-founders, Riley and Edward, and they also came from a molecular biology background and genetic engineering, so they were a lot more well-versed into the world of biotech than I was. All I knew about biotech was bioreactors and how to manufacture antibodies. And so with them, we just started thinking of ideas. So 2012, CRISPR, not yet the global phenomenon that it is. And we're just talking about ideas. And one of the trends that we had been observing quite closely and that we were excited about was the cost of sequencing, you know, crashing. We've all seen this sort of graph from the NIH where the cost of sequencing is going down. And so therefore the problem that comes out of that is actually a data management problem. And we thought, okay, well, here we are, 3 master students at university. We don't have any research in the lab, we don't have any patents, but we can start to code, right? Like, we can start to learn a language and start to code and just make algorithms and search engines to try and search through DNA more effectively. Because one of the things that we thought about, and one of the things that one of my co-founders experienced when he worked at Genentech, was he always found it quite difficult to search for DNA in a sort of smart sense, right? To say, actually, instead of saying, well, I'm looking for ATCG, more saying, well, I'm looking to make a plasmid that does ABC, so more functional search. And then actually the algorithm's telling him something like, okay, well, actually, your neighbor has a plasmid that's already doing what you need, except it has a different antibiotic resistance gene in it, for example. So, you know, go there, and this is how you'll clone out the bacterial antibiotic gene and replace it with yours, so on. So it's more smart searching algorithms. And so at the university is a very safe environment to think of new ideas and innovate, right? So that's one of the sort of things that I think I'm so jealous of all of you. They're still at university. It's so safe, and it's a great place to just question and learn and to ask professors. The day you leave university and you become a corporate, you become evil corporations and nobody wants to talk to you anymore because you're there to make money. Whereas when you're a student, you have no money and you're there for the academic purity of the idea. So it's a great position to be in. And so we use that, right? We started asking many questions to lots of different professors, and they just encouraged us, hey guys, just write a business plan. Okay, well, what is a business plan? When you Google what is a business plan, there's millions of articles. So again, it's easy to go out and just learn and teach yourself what to do. And so you write a business plan, but it's useless on your desktop, right? You need people to judge it, so we submitted it to all these different competitions, and one of the competitions that we submitted it to won, but the only way to get the money is if we made a company and had a business bank account. So again, you Google, how do I get a business bank account? It's actually very easy in the UK. Just £100 and you've got a company, and then you go to Barclays or HSBC and you say, hi, I'd like a business bank account. So that happened. So we get the money. So this is still 2012, like pre-CRISPR. And so we're out there just developing prototype algorithms using that money. And we come across some people we had met whilst we were at university, and they encouraged us to go and sell our algorithms. And they said, guys, just go and meet clients, okay? You've got a technology that you think will help people, try and sell it. And what we didn't really realize was what they were trying to get us to do was obviously test the idea in the market, throw it against the wall and see if the spaghetti sticks to know it's ready. But also learn how to sell, because if you're going to build your own company, you have to sell your idea as a CEO, you have to sell the business plan as a CFO, you have to sell the products as a salesperson. So you go out on the market and you start selling, and you get a lot of rejections. You get a lot of rejections, but all those rejections have really useful things that they teach you. And one of the companies that we sold our algorithms to said, we like your algorithms, we don't want them because we think the application you have is not useful for us, but we have this new thing called CRISPR. Can you use your search algorithms to find CRISPRs in genomic data that we have? And by the way, we'll pay you for it. And I just thought, this is our first contract, right? So I go back to the office, I'm like, guys, we have a contract, but it's not to do the original idea. We now need to search for CRISPR. And everybody's like, what is CRISPR? We're now sort of March 2013, so we searched for a few papers, and there's a few papers from Martin Jinek and Patrick Su that had just come out, and so we realized that actually CRISPR is this thing that is gene editing, so very new. But that first contract got us to develop the CRISPR technology, and again we went out and sold it. Right, our investors and our backers said, guys, go out and try and sell this new thing you have, and that's how we realized actually the CRISPR market was a lot bigger, and the wave was going like this for what we were selling. And so the sort of the moral or the learning that we got from the story of how we started the company was just we got out there. It's painful, and it's painful because it's humiliating many times, but at the same time, it's how you refine the idea. And if you beat up the idea long enough and it survives, and the product survives, then actually you've got something fantastic. I'll just tell you, before I started Desktop Genetics, I spent 3 months at a venture fund called Flagship Ventures. And it's a Boston-based biotech fund, and they do entrepreneurship as a system, right? Nubar, the CEO and founder, he has a formula for entrepreneurship. And it's as simple as beating up the idea, basically, until it survives. And the more it survives trying to be killed, the sharper and the better the idea is. And so that's really what the process of starting the company was. We just went out there and just started talking to people and really refining the process. So that's how we realized CRISPR was sort of the next big thing, is when we went out and spoke to people about it. And the reason why I'm making such a point about it, is that it's actually really counterintuitive, right? Because people always say, well, somebody's going to steal your idea, somebody's going to just take it and run. Nobody will have spoken to more people than you about your specific idea. And so it's hard to go out and overcome the fear that people are going to steal your ideas. And if they do, it probably wasn't such a great idea in the first place, because somebody else could have just thought about it. But you will have learned something in the process.
Okay, thank you. So that's the story behind the idea of doing something with CRISPR. But can you, like right now, the Desktop Genetics, which is your startup, combine CRISPR, artificial intelligence to do RNA guides. So you have combined all the cutting edge and the buzzword in one place to do one startup. So can you explain again, you know, as simple as possible, what is the tech behind, and what are your customers? What is your startup, and what is the product that you have?
Yeah, so Desktop Genetics is a software company that focuses on CRISPR and artificial intelligence. And it's not just a set of buzzwords, although they are right now kind of some of the hottest trending words on Google. Artificial intelligence, you know, machine learning, statistics, basically, at the end of the day, is really what we do. And we use computers to try and just augment our ability to analyze data. What big data was 5 years ago is now artificial intelligence. So, you know, 5 years ago, my pitch deck was CRISPR plus big data. Then it moved CRISPR plus machine learning, and now it's CRISPR plus artificial intelligence. What will it be in 2 years' time? I don't know. But what the company does effectively, if I'll just recap what CRISPR does as a technology very quickly. You have an enzyme, a nuclease, molecular scissors that cut, and then you have a guide RNA. So a short RNA molecule that will guide this nuclease to a particular part of the genome where it can affect a change. One of the things that we try and predict, and one of the things we try and understand, is why does one guide cut well at this position, but some other guide won't cut so well in this other position? Because very quickly, working with CRISPR, we realized that not every guide was created equal. Why is that the case? What is it about the sequence of the guide, or the position in the genome, or the nuclease interaction with that whole system that makes the guide RNA less effective or more effective in another setting? Question number one. Question number two is what makes a guide really specific, so very targeted, it'll cut there and only there, versus a guide promiscuous, which is actually going to introduce changes in many other parts of the genome that we don't want to edit. Again, what is it about that sequence that has this property? And so as a company, what we do is we develop algorithms to predict those two factors so that we can then inform rational design of experiments. By informing the rational design of an experiment, we allow scientists who are in the drug discovery space or in the fundamental research space to save time and to save money on experiments that are ultimately, you know, optimized by using the right guide RNAs. And then when we look at a clinical setting, we look at actually optimizing guide RNAs from a safety perspective and saying, okay, well, what we're trying to do is help people at least characterize a safety profile of a CRISPR therapeutic by having a data analytics approach and a data predictive approach, so that companies who want to commercialize CRISPR-based therapeutics have a much greater understanding of the safety profile in terms of where else it's going to cut, so that they can inform the regulators and also look at these areas to see if functionally it has an impact. Because remember, right, even if CRISPR cuts in other parts of the genome, the question still remains, does that matter? And if the cell survives and if the cell continues to have the same functional behavior as it did before, except for the thing that you did want to change, then actually maybe this off-target is something that we can tolerate. But if the off-target lands in a region that, for example, is oncogenic or a tumor suppressor, at that point we actually care about that potential change, and we want to run some assays to check that. And that is now permissible with artificial intelligence, big data, because we go and tap into large databases of Cancer Genome Atlas, of ClinVar, things like that, where we have a lot of annotations about the genome, so we can try and predict not just the cut is going to happen at this position, but also these are the potential impacts of this cut. And as a result, as a researcher, we recommend you run the following assays to test for the off-target at position A, off-target at position B. And so we rely on next-generation sequencing, we rely on bioinformatics and artificial intelligence to learn from data. And where does the learning come from? Because we sell, as a company, we sell to a lot of researchers in the industry, and we partner with a lot of these researchers. They also license the data back to us, and we learn from the data, right? So if we go and say, hey, we think we've designed a really good guide RNA for you, and then they test it, and it's not quite as good as we thought, we learn from that. And so the next time we design the guide RNAs, we know actually with that promoter in that system delivered as a plasmid or as a lentivirus, this was the efficiency. It was lower than we anticipated, so that we get to readjust the algorithms as a result. So it's a sort of continuous learning process.
So you have told you told us about the fact that you learn a lot from the customer, and you even started the product from the first customer. And so right now your startup already exists for many years, at least few years, and at some point you sold the company to one of your customers, and also at that point you became the CEO of the startup. Can you tell us about the pathway that the startups took?
So the company is just celebrated its 6th year anniversary. And if I was to tell you the whole pathway, we would be here very long, and so I'm happily, have a beer with you and tell you about all the ups and downs. But to say that it was a linear journey and to say that it was a straight line up is not true. It's a roller coaster, and it's a daily roller coaster when you are in a startup environment. You wake up one morning and you're just, you're going to be on the cover of Forbes magazine, and that by noon you're thinking that you're going to have to shut the whole thing down, and by 5 p.m. again you're thinking this is it, we've made a breakthrough. So on a daily basis, it's a real roller coaster, and so having co-founders is very helpful to kind of dampen that effect. And so one of my co-founders when we started the company was the CEO, and I was in charge of finances and operations. And what I was doing was getting money in and making sure we didn't spend too much money out. And by getting money in, you go to speak to investors, you go speak to customers, and you go speak to grant funding bodies, right? So that was kind of my job. And then in December of last year, we decided with the board of directors that actually we should look for a strategic partner to merge the company with. Because as a software company in biotech, you have a very unique and unusual position. You iterate so much faster than the rest of the industry, right? You're a tech company. For us to add a new algorithm, when a new Cas9 was discovered, the next day we would have it in our algorithms, but no other lab was using it, right? So you can move so much more quickly than a traditional biopharmaceutical company. But what you always need is data. And as a software company, without access to your own lab, how do you get data? You partner with academic institutions, you partner with customers, and partnerships take a long time to establish, and they also don't always work. I think we've signed maybe 15 partnerships, and it's probably 6 or 7 that just crashed and just didn't work. And I don't know fully the reasons what makes a partnership work or not work. If I did a postmortem, I'm sure there's a whole bunch of different reasons. But effectively, we had to partner out to go and get this data. And at a certain point, we said this is quite frustrating. We need access to our own labs. We need access to a structure that has also more clinical expertise than we do, because we were getting a lot more interest from customers who were translating their CRISPR technology into therapeutics, and that was kind of the new wave of things that was really carrying us. And so we went out and approached our customers who were in the industry, our suppliers as well, and we said, hey, we're looking for strategic funding or strategic partner to merge with. And so we had term sheets for acquisition, and in June we closed the acquisition of the company to a customer of ours, a company called Selixir. They're a stem cell regenerative company developing a stem cell therapeutic for heart failure. And they have, a world-class clinical expertise team. They have experience in obtaining CTA and IND filings. They have a GMP manufacturing for cell facility. They have capacity in their lab. So we just thought, this is fantastic. It ticks all the boxes. And so as part of that acquisition, we transitioned the whole team. And, that's normal and that's natural in the process of a startup where people have different cycles, right? And some people wanted out. Some people thought, okay, great, this phase of the company now is something that I don't want to be involved in. And so people left the company and I took over as CEO. But it's just to say that as co-founders, the relationship you have at the beginning on day one evolves, and every week and every month and every year it evolves and evolves. And as a board and as a team of co-founders, you have to be aware of that evolution and you have to accept it. And it's okay for people to exit businesses and move on. Because when you're a subsidiary of a larger company, the dynamics change and so on and so forth. So that's how we got to where we are today. That's the company, and it's been like this, and then I'm sure it'll continue to be like this because that's the nature of business.
But that's bring the next question. You told us that being an entrepreneur and the startups, it's a roller coaster every day. It's up and downs every day. So I guess that it would be much easier to just move to a big company and work from 9 to 6 p.m. or whatever. But I guess that you have never experienced this big company life and non-entrepreneurship life. So what's the gut feeling that you have that really drives you to this entrepreneurship lifestyle? I'm
not sure that it's a gut feeling so much as also being aware of, you know, the opportunities that are presented to you. The previous speaker here made a really good point about it, that the opportunities were there, and it's about your alternatives, and it's always about your alternatives, right? And you're always choosing the right choice, or hopefully you're always making a choice in the context of multiple options. And if you're able to create that scenario where you're saying, okay, well, now I have 3 options ahead of me, I will choose this one because it's what I want to do, it's my favorite one, then you're in a good position. When I started Desktop Genetics, it was, you know, we left university. I had a job offer from a big pharmaceutical company to do bioproduction, something I had worked, you know, 5 years at university to study, and that was, you know, what I wanted to do. So I turned that down because I had an opportunity to do a startup, and I thought, actually, here's an opportunity for us, you know, because we had a company with a business bank account, it was amazing, with some money in it, right? And I had this versus a job offer, and I thought, when will I ever have this opportunity right here again to do something where I'm given free money that I won to just test some ideas out? Because, and I think a lot of you probably share a similar kind of feeling, is that once you get into a company, these companies can provide you with a long-term career. But once you're in the machine, how can you exit the machine and take the risk that a startup presents, right? It's really challenging. And I was afraid of that. I thought, if I join this large company, all I'll want to do is get promoted and rise and rise and rise, because that's the natural, you know, environment that you're in. When will I ever decide, actually, you know, let me go and spin off my own thing, take no salary for 6 months or a year, and completely risk everything? And so it was about opportunity, and it was about what was there and making the choice. And so the gut feeling was, hey, I have this, I don't think I'll have it again, and I don't think that if I join a large corporate, I'll ever really make the jump out of it. So let me take this opportunity now, because if it doesn't work out, I got a job in the first place, so I'm pretty sure I could get another job again. Or if it doesn't work out, you know, you're young and you just ended university and you don't have a family, or you don't have a mortgage, or, you know, those things, suddenly if you can sort of put yourself in that position where you don't laden yourself with sort of liabilities or risk, then actually taking the risky choices is a lot easier to do. So I made that jump, and I thought, hey, you know, this is now or never kind of thing. And then you get addicted to it. That's the crazy thing about startups and entrepreneurship, is once you're in, right, and once you're thinking about your idea, it's not 9 till 6, it's 24 hours. Like, you start dreaming about your idea, and then you don't even remember if you send somebody an email or if you dreamt that you send them an email. That's when you know you have to take a bit more sleep. But you know, you get addicted to it, and that propels a culture of self-success and of success with your co-founders, because people feed off positive energy like this, right? So even though your idea may be, you know, you might have difficulty communicating it, or people might, you know, give it a bit of scientific snobbery and say, no, we don't know if it's so great. The energy with which you sell it and the passion, right, will keep you driving through those 50 no's until you get that one yes. The comment about the investors earlier is so true, right? It's really hard to get the first investor. The next 6 is pretty easy. And the reason it's hard to get the first investor is because you get through 50 no's before you get a yes. I was just, like, I always have this slide that when I sort of do a slide deck about these things, I kind of map out the number of investor conversations I had and the success rate. And boy, I mean, let me tell you, it's not pretty, right? Like, you're speaking to a lot of people and they give you a lot of no's. I respect the ones that give you a no directly, because then you know you can move on. You get a lot of, this is interesting, you know, let's further the conversation. That's difficult because you're excited about what they have to say, you think that they're interested, but what you need is a decision a lot more quickly, because your time, right, is your most precious asset, because every day that's happening, you're not paying yourself a salary, you need that investment. So really, the investment process is one that's lengthy, and one where you have to put the other party in a position where they're going to decide, yes, I want to continue talking, or no, it's not for me. And that's not that easy, because people are often scared of just saying no and hurting people's feelings. So that's why it's hard to get the first one, a lot of rejection. But then, you know, you get it, and it sort of moves forward. So the gut feeling was just there, the opportunity. Also, the other gut feeling was that there were 2 other people who were as crazy as I was and who believed in it as much as that. So that kind of helps you validate the idea, right? Okay, I'm not alone in this. There are 2 other people who are willing to give up, you know, a job at a particular big company and move towards this with me. And give yourself some time constraints, right? We had some money in the bank, and we said, how long can we make this last in London, realistically, right? London's an expensive city to live in. So what do you do with £8,000 for 3 people, right? So basically 6 months of paying each other like £500 a month to cover maybe a bed somewhere. But more importantly, we said we have to try and get some, the money to pay for like a designer to help us design the website, whatever. All the money actually goes into the company, and you take very little out at the beginning. But you also have to give yourself a deadline and say, listen, if we haven't been able to make progress that we can measure and talk about in 6 months or in 12 months, let's just call it quits. Because again, your time is your most precious asset.
So I have still many other questions, but timing is going. So maybe the last question from my side, at least, what are the next steps for you and for your startup? And maybe they are the same next step, but yeah, that's the question.
My next steps, this is like a new adventure for us. Being an acquired company is a completely new ballgame. So my next step is just to survive that and figure how that works and learn how to manage a company within a group. What that means when you've been acquired, right? You suddenly have to adhere to new processes. So the group comes in and says, this is how you were doing expenses or invoices. No more. Now you do it this way, right? So there's a lot of change management that happens. And it's really frustrating because you've built something for 6 years, right? And it's yours. And you're like, let's say we do invoices or purchases the best way in the world. And this company says, no, now you're going to do it our way. You have to digest that personally. You have to get the whole team on board. So this is kind of the next step for me is learning how to actually, make a successful subsidiary and part of a larger group. But the original mission of Desktop Genetics on actually getting to the root cause of genetic disease and helping companies bring CRISPR-based therapeutics to the market is still very much at play. And so, we're participating in IND filings, preclinical programs, phase 1 studies, and we're hoping to see those come true and have a positive impact very soon in the world. It's actually really exciting that Talon, which is an ancestor of CRISPR technology, Talon is I was kind of talking about it earlier. Talon has had some clinical success. In London a few years ago, it was approved for compassionate use in the treatment of ALL in a little girl called Layla, and she was in full remission. So she was late phase leukemia, no more treatments available, and they used Talon to edit cells in her immune system and reintroduce those cells back to fight the leukemia, full remission of the patient. And so there are these like glimmers of light and hope that actually means that yes, there is a potential pathway for these therapeutics to get to the clinic. The fact that the RNAi, Alnylam therapeutic have carved away already, the guys at Sangamo with the zinc fingers, all of these things are hugely valuable in the industry because it ignites the enthusiasm of the investors and it forces the regulators to actually answer the difficult questions of how we get an RNA therapeutic on the market. It forces the payers to say how much can we afford to reimburse. Like it forces all the questions that make it a reality. So that's the next step, I suppose. It's pretty big.
Yeah, so as an entrepreneur, how do you personally measure your own success, that you are on the right path, and how do you measure the success of the company? Like what are some common markers that you start to see when you're on the right path?
I think every company might be a little bit different, and certainly, compared to Amylon, for example, we're not a therapeutic company, we're more a tools and services company. So our marker and our benchmark is typically revenue, so sales and being able to sell the product, whereas, and when you're developing a drug, you're looking for, it's like experimental success through different phases of progressing the technology. But as an individual, as an entrepreneur, how do you know that you're on the right path? You're able to convince other people and you're able to get other people who previously didn't think about your idea to actually join your company. And I think recruiting people into your company as an entrepreneur originally is one of the most important things. And if you're able to do that successfully, I think that's a mark of success because you get other people believing in what you do. Same thing with investors. But a lot of times in the startup world, the race is to raise the biggest round, to raise the most money, and that's not necessarily the most important thing. That is a very clear marker of potential success, but we've seen also huge failures that have had hundreds of millions of dollars pumped into them, right? And so at the end of the day, I think you also have to be able to go home and say, yeah, I still truly believe in what we do. It's still sound science. It's still grounded in really good things. And I feel good about coming in tomorrow and helping my team. And as long as the others around you feel the same way, then I think that's the most positive marker of success. In a startup, again, the only asset that is truly either well, both the most at risk and also the most valuable, in my opinion, are still the people. And so, you know, it's the most at risk because when somebody leaves in a really small team, it's a huge disruption. But they're also the people that make and break your company. So the ability to attract people, I think, is super, super important. And that would be the measure of success I'd go on.
Oh, sorry. Or something like this to succeed, or not?
You don't need a marketing degree, and you certainly don't necessarily need any kind of, you know, design or communication flair or you know, special skill. But again, it's kind of what I was saying earlier. People feed off the energy, and so they recognize the passion in the topic that you're talking about. So I encounter a lot of people who have difficulty communicating their idea because it's so technical, and you know, they're coming at it from the science. But when you hear a scientist talking to you about their PhD, their master's thesis, whatever, and you can get the energy, that's what's attractive. And I think that's how people really come in, and that's what they latch onto. The technology might be great, the application might be great, but it's the story that you're able to communicate to that person and say, this is why I'm passionate about it, this is why I think it's a great idea, this is why I think you should come and join my company. But to be honest, a lot of people, they don't hear that. They're just like, this guy, this girl, they're electric. Like, I need to work with them. This is so interesting, and I just want to feed off their energy. And I think that's one way that people, if I had to find a common ingredient between all those people, that's really the energy.
So you said that you benefit from a partnership with academia. So at some point, do you think that if you develop, especially if you develop tools and algorithms, you will help also academia to perform his research?
Yeah, so academic researchers have been a huge source of help and promotion for us. So actually we do distribute a lot of products and services for free to academic organizations and academic labs. And we have different models. So some models where we distribute for free in exchange for data. Some models where we just distribute for free because academics are your early adopters. The academic labs, right, they're under a lot of funding pressure. That means that they don't have huge loyalty to a particular solution provider. You know, they're always looking for the best, but also the most cost-effective solution. And so when you have something new to offer, and when you want some beta testers, academic labs will jump onto that, and it's super helpful because you give them your software, and then they start using it and say, Victor, this interface is completely useless. I can't use it. And you know, you want that before you go to Pfizer and Novartis and try and sell it. So the academic labs, you know, I think focusing on how we can leverage that, you know, partnership is the most important for us. So we continue to have free products and services for academic labs in exchange for data, in exchange for feedback. The other really great thing that academics do is they publish. When they publish, they mention you. They say, hey, we use this. There is no better marketing or sales tool than a prominent paper that uses your technology. Like everybody else say, but then to reproduce this experiment, I must use a desktop genetics algorithm. I mean, this is like, so that's why you need a very positive attitude towards academics. A lot of tools and services companies dismiss the academic sector as having no money. Whereas that may be true, where the academic sector has significantly less funding than by pharmaceutical companies. It has something else to offer. So yeah, I really value the academic sector.
Hi. I got a question about the bioinformatic aspect of what you're doing. So you were in touch with CRISPR technology only because somebody came to you with that idea. So what you do is in a bioinformatic development of new software. And my question is about doing a merge between biotech and IA, artificial intelligence. It's how do you do the combination of the two, and how do you help other startups in biotech, for example, to develop that software? And that's what you did through 6 years, to develop that software with CRISPR. But will you develop another software with another biotech, or will you help, as you said, with academic lab, you give for free the tech, and they give sometimes data in exchange, and it's developing bioinformatics in that very innovative way, will you do that in other technology than CRISPR?
Yeah, I think I'd love to. There's just still so much for me to do within CRISPR that I can't see Destilogenics at the moment doing much outside of CRISPR, but there is a huge need for better technology. And by technology, I mean software tech, computer tech in the world of life sciences. I mean huge. Just artificial intelligence as a global kind of concept, for example, image recognition, right? Automated-based image recognition is having massive impact in diagnosis, right? Being able to make more accurate calls than an expert physician. And that's just scratching the surface, because right now we're talking about some kind of clinical application, but in the research setting, why do scientists still have to write things on paper when we can record things digitally, when we can have a much more comprehensive data gathering environment in the lab that allows us to improve the way that we actually record experiments so that we can actually reproduce them? Because all of you know, I'm sure, how difficult it is to read somebody's Nature paper and actually reproduce it. There's so much information missing, there's so many details missing. So for me, technology, computer technology, is actually one of the huge breakthroughs in biology. In fact, it's how CRISPR was discovered, because people were looking at the genome of cells being like, why are they immune? And then they found this repetitive sequence thanks to sequencing and bioinformatics. And they said, what is this repetitive sequence? And that's how CRISPR was discovered. So computers are really transforming the way we do biology. And I would encourage everybody who's in a life sciences setting or any kind of scientific setting to just learn or open yourself up to learning about what a computer can do to help you augment your capabilities in the lab. Because for me, the future biologist is actually a biocoder, right? It's somebody who can do both the wet lab and the data analysis and the high throughput big data analysis. How we deal with it in the company is really expensive because those people are very rare. They cost a lot of money. And so how we have to tackle that problem is we hire a biologist and we hire a computer scientist and we get them to talk to each other and we get them to try and cross their expertise. But you hire a computer scientist, they don't know what an exon is, they don't know what a gene is, they've heard of genomics and they've heard of CRISPR because they read Wired or TechCrunch. And then you bring in a biologist, for example, who's worked with RNA or who's worked with CRISPR for a long time, but Python is foreign to them, machine learning is foreign to them, neural networks is foreign to them. So how do we get them to collaborate? It's just a painful and long process of a lot of communication, but that's the only way we're able to actually bridge that gap. But I think all of you can bridge it in your own studies by learning the computer science side of things. And I always encourage people who do computer science to learn applications and to just read about biology, read about chemistry, just so you know at least the terminology. Because the first thing, right, the first step is communicating with somebody. So if you, as a biologist, I'm not saying you need to be an expert in Python, right? If you want to, please do it. But learn about what coding means so that when you meet a coder, right, and you meet a computer scientist, you guys can have at least a conversation where you're speaking on a similar language. And vice versa. Somebody who's learning Python, R, whatever, they need to know what an exon is, they need to know what a gene is. They should learn about biology, they should learn about chemistry, about physics, so they can have a conversation with the scientist. And once that conversation happens, then magical things come out of that. That's kind of my ideal view of the world, but that's really where I think it happens. And the disruption is out there, and I think everybody has an opportunity to just start. That's why the tech revolution was so great, is this coding is made available and ubiquitous to anybody. So biotech has a huge barrier to entry that people think about because they're like, I need a patent, I need lab data, I need all of that. Whereas tech has a very low barrier to entry because you just need some free time in a garage and a computer and an internet connection. So how do you get into biotech via that avenue is by actually learning about the application, but just thinking about it from a computers and data perspective. And you can do big damage in a really positive way, obviously.
Thank you.
Thank you very much. So we were supposed to finish at 6 p.m. So if some of you have to quit, please feel free to quit. But otherwise, I propose that we might finish at 6:30, and we are going to do our best effort to really finish at 6:30. So Victor, thank you very much for being here. Thank you very much. So, Viviana, can you present the project that you represent, and Luca, can you put the slides? So Liviana is going to present you a foundation. It's a foundation. Well, I'm not going to introduce at her place, but she's going to present you an option. It's an organism that helps you to get money to do, basically to achieve your dream. But I'm going to let you introduce.
Thank you, Celestin. Hi, everyone. Just waiting for my PowerPoint presentation. Yeah, that's it. Okay. Can I have also the, yeah. So I'll just take 5 minutes of your time to present our foundation. So my name is Lavinia and I work for Vocatio. So I'm very happy to be here today and to hear about all these young and passionate and ambitious entrepreneurs and researchers, because at Vocatio we really believe in these young people, young passionate people with projects. So what do we do? Sorry. What do you at Vocatio basically? So if you are passionate about something, if you have a vocation, and if you're between 18 and 30 years old and lack financial resources to fulfill your dreams, to make your project come true, then you can knock at our door and maybe we can help you. So we're a Belgian organization, so we help people from the Dutch-speaking community and also from the French-speaking community. And you also have to have a link with Belgium, since we're a Belgian organization, as I have said. So how do we help people? Well, basically we give grants of 10,000 euros. So I know that in the scientific world and maybe for entrepreneurs, it's not a lot of money, but you can use it for specific parts of your project. For example, for traveling or for a specific training or for an internship somewhere abroad. Something new that we have developed is also non-financial support. So this can be, for example, it can be networking, or it can be coaching or training, or, well, it's mainly based on a case-by-case basis. So since we try to help as many people as possible, we cover a lot of fields. So the projects that can ask for a grant can be one of these following fields. So we have projects that have to do with health, science and technology, but also social and human sciences and everything that has to do with arts. And so we also have panels of independent experts who will analyze all the applications and then vote for our laureates. So if you know people or if you are interested, well, you can apply. That's very easy. So you go to our website, vocatio.be, and then you click on Poser votre candidature or Digne candidature in, depending on the language of your application. Then you just create your account and you get access to the form and to the questions, and you just simply answer the questions, and if you have appendices, you just upload them. So if you're interested, if you have friends or family that are interested, you can still apply, because the deadline for application is on the 16th of November. If you want to have more information, just check out our website, or you can come and see me, because I will hang around. So don't hesitate to come and ask more questions. So thank you very much, and I will leave the word to Celestin. Thank you.
Thank you very much. So just if you must remember something, you might get 10,000 euros to achieve your dream. So that's a good thing to keep in mind. So we were supposed to have one more speaker, but this speaker, he was not able to be here today, and the reason why he's not here is because of his job. And so the reason why we wanted to have him to talk is the reason why he's not here today. So the third speaker was Bob Gosne. He's a guy who is working, who has been working at the International Red Cross in Switzerland. He moved to Belgium to work for the Belgium Red Cross, and then he, in the very last minute, he told us he couldn't make it because he went to Republic Democratic of Congo in the northern region. You have to know that it's the hardest and the most dangerous region in Republic Democratic of Congo. It's a place where you have wars. A lot of people they have guns. It's basically a war on that region. But a few weeks ago, the Ebola epidemics has started also in that region. So basically it's the region where you have wars and epidemics, Ebola epidemics. So he went there and the mission of the Red Cross, everything I'm telling you, it's the thing that he told me. So that's the reason why I'm introducing you to this job, to his job. But the mission, the goal of the Red Cross over there, it's to manage the died people. So they have to get the bodies and manage the bodies because that's the reason and one of the main problem with Ebola is the epidemics aspect. So all the humanitarian actors, the Medical Without Border, the Red Cross, and also the OMS and all the WHO. But all those people, they go there and they have one mission. The Doctor Without Borders, they manage the medical camp, and the Red Cross, they manage the dead body. And he told me that it is a very hard missions because the people in that region, they see that those humanitarian helps arrives at the same time that Ebola arrives. So they believe that they often see the medical aids as a source of problems because they see that they came and they think that they bring Ebola in the region. So they are not welcome in that region. So it's very hard. They have to sometimes separate the children from their family because once you have an Ebola case, it's very important to separate the people, the infected patients from the family. Otherwise, obviously, you get the epidemics skyrocketing. So it's a very hard mission, and they went there. He went there yesterday, actually. So that's the reason why he's not here today. But then we still have a very few minutes. I would like to invite Sarah. During our project, our iGEM project, we, as Alex explained, we developed a solution to fight the antibiotic resistance. But it's also a project that aims to fight epidemics. So our very first idea was to fight the cholera epidemics. And in the frame of that objective, we sent Sarah to Benin. She went there for 3 weeks. She met the Red Cross on the field. She moved to the north of Benin. She took a bus for hours and hours to go inside these very hard conditions. Sarah, I'm going to let you explain a little bit about the trip that you achieved, and also the video that you are going to present us.
So Alex spoke to you earlier about our plan to kill bacteria. So we imagined this process following the biggest outbreak of cholera in Congo this year. So I'm just back from 3 weeks in Benin, as you can see. A country hit by cholera epidemic, but preparing itself to be able to counter it in its rainy season. Unfortunately, the country is experiencing a very strong outbreak of salmonellis. Less deadly, but still so. Most patients of I cared for were rolling on the ground as a result of intestinal perforation by the salmonellosis. Donc sometimes they had to wait 4 hours in this state because the operating room program was overbooked. At the moment, there are aquatab chlorine tablets to filter water, but you'll see in the report it isn't easy for the population to use it. So that's why we came up with a bigger project that would treat the water and its source by making it drinkable. And that water is thrown, it will filter the old sewerage. So I apologize because the video is in French, but I'm just back from Benin and we had more time for this. But it will another version in English soon. Thank you.
Thank you.
On se sent souvent impuissant face à tout ce qu'il y a à faire dans le monde. C'est pourquoi notre équipe iGEM UCLouvain s'est attardée sur les épidémies qui ravagent les camps et les villages. Mais au fait, c'est quoi une épidémie ? Direction Cotonou. En Afrique, les épidémies sont très fréquentes, notamment dues à la saison des pluies. Alors, allons étudier ça de plus près. Notre équipe a tenté de trouver un moyen pour limiter les pathologies qui se répandent via les eaux usées. Tangueta est une région au nord du Bénin actuellement sujette à une épidémie de salmonellose dont le mode de transmission est orofécal. Tous les villages n'ont pas accès à l'eau potable. Lors de la saison des pluies, l'eau contaminée par les déjections ruisselle dans les puits et facilite la propagation. Dans certaines régions, la population consomme l'eau de la rivière. Nous avons été chaleureusement accueillis par l'hôpital Saint-Jean-de-Dieu de la ville. Ce patient, atteint de salmonellose, s'est présenté avec des douleurs abdominales, des crampes et des vomissements. Trop souvent, les patients se rendent à l'hôpital au stade de perforation intestinale car ils tardent à venir se faire soigner à cause des coûts de soins de santé. Tout aussi ravageur, le choléra se transmet de la même manière que la salmonellose.
La personne vient avec des diarrhées profuses, avec une déshydratation profonde et des vomissements qui s'accompagnent et ça rentre dans l'état de choc. Et si on ne fait rien en même temps, la personne décède. Le traitement urgent, c'est d'abord la réhydratation. L'eau que le patient paie, il faut remplacer en même temps. On alerte la population, en même temps on alerte l'hiérarchie, et on prend les mesures pour pouvoir mieux soigner. Ça se repose sur 2 choses, il y a la réhydratation et la doxycycline. C'est ça qu'on utilise pour pouvoir les sauver.
Est-ce qu'il y a des risques de résistance parce que la doxycycline, c'est quand même un antibiotique assez puissant?
Oui. Chez nous ici, si les patients viennent tôt, je pense qu'on arrive à les récupérer. Donc, dans le cas de choléra, on ne peut pas dire qu'il y a de résistance. Peut-être que la personne reste à la maison, il prend un peu de doxy, il fait une automédication. Dans ce cas, il meurt. Mais c'est la déshydratation qui les tue souvent. Ce n'est pas gratuit. Et comme ils n'ont pas les moyens, ils préfèrent aller chez le marabout. Et le marabout fait pour lui. Et tout ce temps-là, ça prend du temps. C'est le problème de moyens financiers, c'est surtout ça. Ils savent que s'ils viennent à l'hôpital, ils vont dépenser. Mais comme ils n'ont pas les moyens, ils restent chez eux ou bien ils viennent tard. Il n'y a plus de risque de transmission dans le village. L'autre contamine et la contamination, ça continue. Et il y a aussi les moyens, comme les gens, tout le monde n'est pas allé à l'école. Ils n'ont pas, sur la prévention de choléra, les gens n'ont pas cette notion. Comment il faut prévenir, ils n'ont pas cette notion. Celui qui trouve le repas maintenant, il prend ça, ou bien celui qui trouve les aliments de crudité ou bien de fruits qui sont souillés, ils prennent ça et mangent simplement ça, laver les mains. Donc ça continue. Donc il va falloir qu'on passe de village en village pour sensibiliser la population sur les mesures de prévention Mais ça, là, même si on fait, les gens n'arrivent pas à comprendre tôt, parce que la majorité aussi de la population, il y a d'autres qui n'aiment pas aller à l'école. Donc, c'est ça qui explique beaucoup ça. Dans le cas, si c'est dans les cas de sécheresse, on peut trouver 2, 3 cas par jour. Mais dans les cas où il y a la saison pluvieuse, ça, là, on peut trouver jusqu'à 4, 5 cas par jour.
C'est la même transmission orale?
Oui, c'est la même transmission. C'est une maladie de main sale, comme on le dit. C'est une maladie de main sale, ou bien les gens veulent manger maintenant, ils laissent ça, ou bien on cherche des légumes. Quelqu'un a déjà fait des digestions qui sont là, et il n'y a plus, tout est contaminé, et on ne prépare pas bien, on mange.
Finalement, le choléra, comme la salmonellose, entraîne une forte utilisation des antibiotiques.
Des antibiotiques, oui.
Et donc, ça, au terme, ça va finir par entraîner une résistance dans la population.
Oui, oui.
Encore plus puissant. Donc, finalement, il faudrait plutôt envisager une solution de traiter directement les os,
Oui.
d'éviter cette transmission orofécale, puisque les gens à besoin ont des difficultés pour venir directement se faire traiter à l'hôpital selon leur éducation, selon leurs moyens, également les moyens d'acheter les antibiotiques aussi, parce que ça coûte.
Oui, ça coûte un peu fort.
On va peut-être envisager une autre solution que le mouvement actuel.
Oui, traitement curatif.
Les épidémies.
Pour pouvoir aller sensibiliser la population, si on fait une sensibilisation de masse, ça va réduire encore le nombre qui va venir à l'hôpital. Et c'est ça, on a commencé pendant quelques mois. Et ceux qui sont en périphérie font la sensibilisation pour pouvoir réduire. Sinon, effectivement, on va arriver à un moment où on va arriver au moment de résistance. Et les antibiotiques ne vont plus marcher. Et là, c'est la catastrophe. Donc, c'est vraiment urgent de faire quelque chose.
Bref, vous l'aurez compris, l'idéal serait d'agir en amont avant que la maladie ne puisse se présenter. Une fois que le clinicien a diagnostiqué une de ces pathologies, il avertit le microbiologiste de l'hôpital pour effectuer une confirmation en analysant les germes dans les selles du patient. Nous quittons donc Tangueta et sa nature pour arriver 14 heures plus tard à Cotonou, capitale du Bénin, et nous nous dirigeons vers le laboratoire de l'hôpital universitaire Kamaga. Donc ici, en fait, on est dans le laboratoire des microbiologistes. Et ici, le microbiologiste qui est juste derrière moi, Frédéric, va nous montrer comment il fait lorsqu'il a un échantillon avec suspicion de choléra. Donc il va nous montrer toutes les étapes de la culture, ce qu'ils font pour détecter est-ce que oui ou non dans les échantillons de sel, il y a présence de choléra ou pas. Donc on va filmer ça tout de suite. Donc ça, c'est le laboratoire. Et là, on a Frédéric qui prépare les échantillons pour nous montrer comment il procède. L'analyse se déroule ici en 4 étapes. Étalement sur l'âme, ensemencement, incubation et cuve. Et 24 heures plus tard, le diagnostic est posé. Et c'est maintenant que cela commence réellement. Lorsque les résultats s'avèrent positifs, le microbiologiste interpelle le ministère de la Santé afin d'enclencher la procédure d'information au grand public. Il faut relayer les mesures d'hygiène dans tous les villages. Les enfants de moins de 5 ans sont les plus souvent atteints. Lorsque la maladie n'est pas prise en charge suffisamment tôt, il y a des risques de décès. Nous poursuivons donc notre cheminement, tel que le choléra, en allant à la rencontre du chef du service épidémiologique du ministère de la Santé. Ce dernier nous relate la difficulté d'informer dans les familles analphabètes, ainsi que dans les quartiers les plus reculés. De plus, il existe des régions où le choléra est plus sujet à se répandre. Il s'agit des régions lacustres, telles que la ville de Ganvier, qui me plaît de prononcer Janvier. Donc en fait, ici on vient d'arriver au village de Janvier. C'est un village qui est construit uniquement sur pilotis. Donc toutes les maisons, elles sont sur l'eau. Et donc les gens ont leur maison construite. En fait, ça cause de graves problèmes quand il y a des inondations parce que toute l'eau monte et du coup les maisons sont inondées. Il y a eu la plus grande inondation en 2010. Vraiment, toutes les maisons étaient ravagées. Ici, il y a à peu près environ 11 villages dans toute la ville construite sur pilotis pour 35 000 habitants. Et donc les gens ici qui vivent sont essentiellement des pêcheurs et des contrebandiers qui vivent de la pêche et qui ensuite retournent sur la terre ferme pour vendre les poissons qu'ils ont pêchés au cours de la journée. Il n'y a pas de système d'assainissement des eaux et les gens rejettent leur eau usée dans les lacs, ceux-là même où ils pêchent leurs poissons. Ils se fournissent de l'eau moyennement potable dans les puits en profondeur du lac. Dans ces villages, il n'y a pas de système d'assainissement des eaux et les gens rejettent leur eau usée dans les lacs, ceux-là même où ils pêchent leurs poissons. Ils se fournissent de l'eau moyennement potable dans les puits en profondeur du lac. En cas de présence d'un cas suspicieux, les ONG s'unissent pour faire une prévention maximale. Et tel le choléra, notre chemin s'achève au siège de la Croix-Rouge à Porto Novo. Malheureusement, j'étais assez fière de mon interview, mais je n'ai pas enregistré le son.
Donc en fait ici, à quelques heures de notre vol, on a réussi à contacter la Croix-Rouge du Bénin pour avoir enfin rendez-vous et compléter nos dernières informations qui nous manquaient pour le projet. Donc on a pu discuter avec des gens qui traitent l'assainissement des eaux ici, qui ont pu vraiment nous donner plus d'informations concrètes vis-à-vis du projet. Et maintenant c'est parti pour rentrer en Belgique.
Mon séjour au Bénin aurait été plus extraordinaire et je remercie les Béninois pour leur accueil plus que chaleureux. Bon, comme vous avez pu le voir, mon interview à la Croix-Rouge, je n'ai pas enregistré le son, mais j'ai ramené un échantillon de tout ce qui a été expliqué. En fait, ça c'est Aquatabs. Ce sont des plaquettes de chlore. Il y en a 10 par boîte et ça se vend à 125 francs. Donc c'est à peu près 20 centimes pour nous. Et donc une plaquette se met dans 30 litres d'eau et ça permet de rendre l'eau potable pendant 24 heures. Le problème, c'est que les gens ne sont pas toujours éduqués, n'ont pas toujours été à l'école et ne comprennent pas forcément comment ça s'utilise. Il y en a qui prennent un comprimé avec un verre d'eau, ou il y en a qui continuent à boire l'eau après que les 24 heures soient passées. Donc il y a des instructions à l'arrière de la boîte, à l'arrière des plaquettes, mais le problème, ça reste encore la communication. Donc c'est pour ça que nous, on va apporter une solution nouvelle en allant directement traiter l'eau à sa source, en la rendant potable et en permettant à cette eau, une fois qu'elle est usée et qu'on va l'acheter dans les lacs ou dans les autres systèmes où on jette l'eau, de filtrer l'eau qui a déjà été contaminée. Et donc on agit à deux points de vue et on est beaucoup plus efficace parce que Aquatable, on l'utilise uniquement en cas d'urgence, parce que c'est efficace seulement à court terme, et la saison des pluies suivante, l'année suivante, il y aura à nouveau des épidémies sans cesse. J'ai eu l'opportunité de faire un stage médical à Tangueta. La cour que vous voyez là est à la fois salon, cuisine, sanitaire et dortoir des familles hospitalisées. En effet, les gens viennent de loin pour se faire soigner et certains à pied car sinon ils n'ont plus d'argent pour se faire soigner. Les familles sont réveillées la nuit par les fortes pluies de saison qui les arrosent. Au service de médecine interne, la majorité des patients hospitalisés sont suite à une péritonite engendrée par la salmonellose. En pédiatrie, la moitié des enfants souffrent de dénutrition sévère et l'autre de paludisme entraînant un état comateux et l'anorexie. Parfois, les gens sont hospitalisés et on ne sait pas avancer dans le diagnostic car ils n'ont pas les moyens de payer la prise de sang ou l'échographie. L'hôpital offre parfois les soins via les dons mais ne peut se permettre de le faire pour tous les patients. J'ai énormément appris de ce séjour et ce dans tous les domaines. Je ne voulais pas juste revenir avec des images, c'est pourquoi nous organisons une collecte de fonds pour l'hôpital Saint-Jean-de-Dieu afin que les patients qui ne peuvent se permettre un coût puissent bénéficier tout de même de soins. Lors de notre participation à cette compétition internationale de biologie synthétique, nous espérons transmettre que nous avons tous une responsabilité envers chacun et tous une possibilité d'action. Enfin, même plusieurs.
T'entends mon cœur?
Well, thank you very much. I'm sorry because I said that at 6:30 it will be over, but it's even later. But thank you very much for being here, and I'm very glad that we could make that even happen. Well, thank you very much. Thank you very much. And we propose you, for those who want, we propose to have an after-event drink in one of the bars in Place de Luxembourg. So we will offer a drink, at least the first drink, to anyone in one of the bars. So we invite you to, for those who want, of course, but we invite you to have an after event in Place de Luxembourg. We are going to show you the bar because we have a deal with one of the bar to get those tickets. Well, thank you very much. It's important that you might interact and use that after event as a networking opportunity because, as Victor said, it's between the it's during those after event, during those networking time that you find ideas, that you find co-founder, and that you find you know, many opportunities. So thank you very much.